Hello, my name is Rahul Parmeshwaran. I am a technical marketing engineer with Cisco, here to talk about Cisco's IP Fabric for Media. It's a solution we built to help the media and broadcasting industry to transition the workflows from SDI to an IP infrastructure. So when we started this journey in 2016, we really had a choice, right? Some of them said, hey, just give me a switch. I know your switch can route multicast and unicast. But when we studied about the industry, what we learned was that there are some unique challenges that this industry has that no other industry has. And the reason why these challenges are unique is because of the kind of workflows that goes through this IP fabric. So first and foremost, when we talk about uncompressed video, it's typically 1.5 gig or 3 gig or sometimes even 12 gig per signal. So that's lots and lots of bandwidth transitioning the network. So you need to build a network that is reliable. And the reason why it's reliable is because there are at times live such as the Super Bowl or live newscasts that's being carried by this network. And secondly, you need to have a flexible architecture because you have the option of deploying this network inside an OB truck or inside a studio, so you really have to be able to support different kinds of deployments. Third, you need to provide enough visibility to what's going on in the network so that you can efficiently troubleshoot the network. Now, timing is extremely critical as all of these endpoints in the studios need to be time synchronized. So we'll talk about how we go about solving that challenge. And finally, how do you secure the network, right? Now that you have everything in IP, how do you prevent an unauthorized endpoint from participating in the network? And that becomes a priority as well. And finally, to be able to convince this industry to move to IP, it's really, really important to ensure that we preserve the current operations that these broadcast engineers are used to. So we really don't want them to relearn the way they interface with their control systems. So let's just talk about each one of these challenges in detail and how Cisco went about solving them. So reliable network, right? If I were to build a network, by running PIM or ECMP, what could happen is, because of the nature of the traffic, it could result in all your video traffic hashing along the same uplink and congesting that uplink. So by default, network is not bandwidth aware. And what Cisco did is we came up with this unique protocol called NBM. It's a process running on NXOS. And all it does is it makes PIM bandwidth aware. So the same kind of workflow now, when we have NBM running on this network, would look something like this. You see, all the 2110 flows are load balanced rather than hashed. So you get a good distribution of audio, video, and ancillary across these available links. So this results in a network that can guarantee that when the operator does a take, that the flow will go through without oversubscribing any uplink. Second, architecture of choice. So I was telling you, right, we have customers who've deployed the network inside an OB-WAN or inside studios. So typically, inside an OB-WAN, they use a single monolithic chassis that resembles an SDI router. Whereas in studios, they want the flexibility to do a spine and leaf architecture. Now, Cisco is uniquely positioned to do both a big chassis deployment, a spine and leaf, and we've also extended our architecture to support a hybrid spine and leaf. So a customer can start small, by infrastructure with a single spine, but expand that by adding more leaves and creating a hybrid spine and leaf architecture. So this is the flexibility that our solution offers, which makes us unique in the industry. And not only that, now that you have a deployment in one studio, you want to be able to interconnect studios across your geographies and extend flows across them. Now, remote production is a popular use case, and we do that by enabling the ability to extend your network across sites and move uncompressed feeds from any network to any other network. So we have customers utilizing NBM and multi-site to do remote production, and they have been extremely successful in doing so. Now that you have your network, moving packets reliably, how do you go about operating the network, right? Now, there was a very, very big misconception of FUD in the industry where they said, hey, in the STI world, I knew what my ins were and what my outs were, but in the IP world, it's all a black box to me. I have no visibility to how these flows are going through this network, so I can't troubleshoot this network efficiently. Now, what Cisco did is leveraging telemetry, our switches stream their state to a collector running on Cisco's DCNM. So we are uniquely able to provide you the end-to-end path visibility of every single flow in your fabric. So you can actually visualize how that video flow is traversing your network, how the audio flow is traversing the network, and do this on every single flow as it traverses your network. And not only that, we also give you the option of looking at the bit rate of every single flow. So you want to really know if that 3 gig camera is actually operating in 3 gig, all you log into DCNM and check the actual bit rate coming from that camera. And again, it's very important to realize that we do this on every single flow in your fabric. It doesn't matter what kind of architecture you go with, a single big chassis, a span and leaf, or a hybrid span and leaf, you get complete visibility to flow path and the flow bit rate. And we added this feature which is extremely unique and something that I'm extremely proud of that Cisco is able to do is we have the ability to look deep into the packet, look at the RTP sequence numbers, and look at gaps in this RTP sequence numbers. So what does this mean, right? So when you are moving your 2110 flows, they're typically RTP flows. It could be 2110 uncompressed or in the compressed world as well. As all these flows are RTP flows, they carry a RTP header. Our ASIC looks at these RTP headers and detects any gaps. So whenever you have that issue where you're seeing bad video, we can pinpoint what exactly is causing that bad video and really reduce the time it takes for resolving those problems. So as an example here, let's say that you've built a multi-site network. So you have 2 networks and you have a WAN network in the middle. You turn on the feature across all your switches. So you have this RTP monitoring going at this WAN edge and at the border leaf. So let's say your service provider dropped the packets, right? And you really don't know if it's a problem within your network or at the service provider. The feature running on this WAN edge switch can tell you, hey, saw that they were compromised, they were lossy. The fault is on your side and not mine. So this is what Cisco enables the industry to do it, and like I said, we are uniquely positioned to do this because of the capabilities we have within our ASICs. And this is a look in DCNM, so we can pinpoint exactly where that flow is encountering the drop. Now, I come from troubleshooting networks. Right? Before I became a marketing engineer, I spent most of my time troubleshooting networks, and it took us several hours to even find out where exactly was the problem happening, right? So now you can really spend as little, I mean, you'd get this information in seconds, and the DCNM really pinpoints where exactly the problem is happening. So at the end of the day, right, you can resolve your problem in a timely fashion, rather than spending hours and hours trying to figure out, hey, what's going on? Now timing, right? So it is very, very important that all your endpoints are synchronized, and we do that using PTP. Now Cisco has a robust boundary clock implementation network. So what we do is our switch slaves off the grandmaster, and then the switch becomes the master for the slave connected to it. So by distributing PTP using take grandmaster, right? So if you implemented your network using transparent clock, which is another way of distributing PTP, you still put a lot of load on the grandmaster. But we support a very scale PTP boundary clock functionality, so you can build a scaled out environment and distribute this functionality across different switches, and which enables you to scale exponentially. And not only we, clock functionality, using telemetry, so stream the PTP state at every boundary clock to the same DCNM. So now you can drill down and find out, hey, what exactly is my PTP offset, right? How is my switch time compared to the grandmaster? And if the offset is too high, you're alerted saying, hey, something is wrong with your PTP, so you don't have to wait until your endpoint starts complaining that something is wrong. Proactively, so that you can, correct it. So all of this is available today with DCNM. And a topic that a lot of people ignore is security, right? Talk about, hey, I want important because you might be recording a show that you don't want anyone to see, right? And today with IP, nothing stops me from taking my laptop, running a VLC, subscribing to a feed. So how do you go about securing your IP infrastructure? With Cisco's solution, we do that using host policy. So you can create this whitelist policy wherein you deny all endpoints by default, and only the authorized endpoints are allowed to either transmit or receive, right? So you can say, hey, these are the list of my authorized sources. These are the list of my authorized destination. Granted, saying, okay, these sources can only transmit to these groups. These destinations can these particular groups. So that way, control of how flows are being routed, who's allowed to receive what flows. And we also add security to the flows because remember, right, the bandwidth that you have provisioned in your infrastructure is designed with the assumption that certain endpoints only consume certain amount of bandwidth. So the camera is supposed to do 1.5 gig HD and does 1.5 gig HD only, but accidentally the operator turns it in 3 gig HD mode. Now, if the system allows this camera to operate at 3 gig HD, you might compromise or eating bandwidth that you would have reserved for some other. So what we do with Cisco is we enforce a flow policy wherein we ensure that no one is allowed to transmit at a rate higher than what that endpoint is authorized to transmit to. So as soon as we detect that a sender or source is transmitting at a higher rate than that you've provisioned, we police it and we notify you saying, okay, something's going wrong, go ahead and correct it. Giving you a reliable fabric with all the visibility, but we give you all the tools to make sure that your fabric is secure at an endpoint level and at a flow level as well. And finally, how do you, now you have this built and running, but how do you really empower or enable the industry to move to IP? We do this by partnering with our ecosystem partners. So Cisco has a very large ecosystem partners. So we work very closely with some of the broadcast controllers out there. So that way what we do is we abstract any complexity one may perceive with IP by working very closely with the broadcast controller and exposing some APIs through which the end operator can continue operating their equipment just like API, right? So you could still use your control panel to route a certain source to a certain destination. All of that can remain the same, but everything that's happening in the background is IP. So you get the best of what IP offers, which is flexibility at scale, which is reliability, which is the ability to reuse cases, and we also hide any complexities for one to adopt this technology. So finally, talking about some of our very successful customer deployments. Now, we created history with Arena TV, partnering with Grass Valley, where the English Premier Game was broadcasted in 4K using our technology, powered by Cisco and Grass Valley. Another deployment that I'm very proud of is we have a studio, a brand new facility in the US leveraging our technology. So they have a span and leaf infrastructure, and they not only use the fabric for production, they have incorporated other use cases such as graphics, editing, playout on the. Again, this makes this whole move to IP so much meaningful because you can reuse to not only do just one use case, but many other use cases that the media industry has. Other deployment is a master control room with Imagine that we have a customer in Brazil that we're proud of, and also one with Lavo in Florida, right? So as you can see, we have deployments in different types of architectures, different types of customers, and with different types of partners. So, and lastly, what we our own technology for our own event, right? So for those of you who are not familiar with Cisco Live, it is the biggest annual conference that Cisco has, where it's our CEO who goes on stage and delivers the keynote, and we convince Cisco TV to use our technology to produce the entire content live. So this was a eat your own dog food story, right? Because we were successful in producing the entire content over IP, and it just went so smooth that no one realized that everything was happening in IP. So we are here to tell you that it's no longer slideware. We actually have deployments in production, and if I have to really, the few takeaways I want you to go with, when you evaluate, hey, what kind of network do I want to deploy, always remember it's just not about moving packets around. So you need to ask yourself, hey, do I have a network that's reliable? Do I have a network that's secure? Does the network give me enough telemetry that helps me visualize what's going on, so it helps me troubleshoot my network efficiently? How well does it distribute IP? And then how can I make sure that my end operator experience remains the same? So with Cisco, we've basically answered all of these industry challenges. So we have this unique solution that we've gone to market with, which has really helped a lot of customers make that move from SDI to IP. So with that, I conclude my session and hope you guys enjoyed it. Thank you.